Hi, my name is Emma Reed. I'm a math teacher. I teach 8th grade. And today we're going to continue our Exponents in Scientific Notation unit. And we will be talking about applications of arithmetic with powers of 10. The big question for today is how can powers of 10 be used to support calculations involving very large numbers? Before we move on, I want us to talk about the words arithmetic and calculations. So when we do mathematics, it's a lot more than just our operations, right? Multiplication, division, addition, and subtraction. So we want to separate this idea of arithmetic and calculations, which can support us solving problems in math, from the bigger problem solving that we do. So we might need to do some calculations with very large numbers, but what we need to focus on first is deeply understanding the quantities and relationships we're dealing with. So we're going to practice a routine today during this lesson called capturing quantities, and that's going to make sure that before we do our operations or our calculations, we know exactly what the relationships we're working with are. Okay, so move ahead with me to slide A, where we'll work on our introduction and launch. So this warm-up is going to focus on what information do we need. So consider the following questions. Then state what information you would need to be able to answer each question. What information would you need to answer the following questions? How many meter sticks does it take to equal the mass of the moon? And if all of these meter sticks were lined up end to end, would they reach the moon? Take some time and consider what you would need to know to be able to answer those questions, and list your thinking in the blue box. Once you've had enough time to think about each of these questions and write your lists in the blue boxes, we'll move on together to slide B. Okay, so now we're into our Explore section, starting on slide B, and this problem is called Meter Sticks to the Moon. So use the information in the box and number lines to help you answer the questions. So we're given some quantities here. The mass of an average classroom meter stick is roughly 0.2 of a kilogram. The length of an average classroom meter stick is 1 meter. The mass of the moon is approximately 7 times 10 to the 22nd power kilograms. The moon is roughly 3 8/10 times 10 to the 8th power meters away from Earth. How many meter sticks does it take to equal the mass of the moon? Show or explain your reasoning. So at this point, we're going to work on our capturing quantities routine, which is going to help us look for and represent quantities and relationships. And the reason why we're going to practice this today is because it's going to help us think like mathematicians to find quantities and relationships in word problems and diagrams. So let's now go back to our problem, and I'm going to ask that you create a diagram that you think represents the important quantities and relationships in this problem. So think again about our question, how many meter sticks does it take to equal the mass of the moon? And try to decide, based on that question, which quantities and relationships are important. And you can sketch, if you're using Pear Deck, you can sketch directly on this slide to show your diagram. Otherwise, grab a piece of paper and a pencil or open a Jamboard and try to show the quantities you think would help answer this question and how they are related to each other. And when you're ready to move on, we'll look at some other students and how they represented their thinking. Here are 3 different ways that students represented some quantities from this problem. So take a moment to look at all of the representations. Now we'll look more closely at student A, student B, and student C's thinking, and we'll ask ourselves, what are they representing? If you are able to work with a partner at this point, you'll share your thinking with that partner. Otherwise, you're going to think to yourself using this sentence stem. They represented blank by blank. So looking at student A, say to yourself, they represented blank by blank. And then we can move on to look at student B. Same sentence stem, they represented blank by blank. And again, you're thinking about the quantities or the amounts that we're measuring and their units, like kilograms or number of meter sticks, as well as the relationships. So how do student A and student B show different relationships? Do you agree with one of them, both of them, neither of them? Those are the things you're asking yourself now. And then finally, moving down to look at student C. And think back to our question from before. They represented blank by blank. And then let's zoom back out to look at everybody's thinking. Now you're going to ask yourself, who correctly represented quantities and relationships that would help you answer our question? Or if you feel that none of these students did, how does your representation represent the quantities and relationships that will help solve this problem? How are these representations similar or different from your own? Now that you've taken time to draw your own diagram to represent the important quantities in this problem, and you've had a chance to look at some other students' ideas, come up with an answer to this question. The diagram should support you in figuring out what operation would be the most logical, and in many cases there's more than one strategy that would work. When you're ready, move on to slide C. On slide C, you're going to use the information on the box and number lines to help you answer this question. You already have an answer now, so you're going to label the number line and plot your answer from slide B for the number of meter sticks. Once you've plotted your answer on slide C, we'll move on to slide D. And you can see on slide D, we have all of the same information. The new thing on slide D is that we have a different question. So we're going to read our question here. If you took all of the meter sticks from the last question and lined them up end to end, will they reach the moon? If yes, how many times farther will they reach? Explain your reasoning. So I suggest you use the same strategy from before. Based on this question, really these two questions, what are the important quantities and relationships? How could you show how they're related to each other with a diagram? And how could you use that diagram to help you answer this question? Take your time here. When you're ready, we can move ahead to slide E. On slide E, it says 1 light year is approximately 10 to the 16th power meters. How many light years away would the meter sticks reach? Label the number line and plot your answer. Again, I highly suggest using the strategy that we tried before, asking ourselves what the important quantities and relationships will be that we need, drawing a diagram to show how they're related to each other. If you want, you can move back in the video and look at the other diagrams from other students. And finally, once you've answered slide E, we'll go on to slide F, where you will record your response to the focus question. How can powers of 10 be used to support calculations involving very large numbers? In the future, when you look at problems with a lot of quantities, I hope you come back to the strategy of creating a representation to help you see the relationships you're given. Remember to think like a mathematician and have a beautiful day.